Today I'm going to be talking about translation in geometry. So this is a sheet I prepared earlier. This was the initial drawing we were given, and I actually did axial symmetry, central symmetry, translation and rotation anti-clockwise 90 degrees. So we began by doing axial symmetry from here to here through this axis. Then we did central symmetry where we bisected the line and brought it through the center, which is labeled point O. And then this is translation, which I'm going to talk about today. So for translation, basically what we're doing is it's like we're picking up this object and we're moving it somewhere else on some other location without distorting the image or changing the size or orientation. So this is easily confused with axial symmetry because axial symmetry flips the object, but it doesn't change the size, it doesn't change the width, it doesn't change anything except the orientation. So you just have to be careful that you don't accidentally do that. But basically for translation it's very straightforward. You will be given point P2 in this example and you'll be given point P3, and that's the only point you'll be given. So the first thing you do is you connect up these two lines. So I've done that in orange here, so you just draw that across. And then the next thing is you will get your two set squares, or I used my T-square in this example, and you put it up against this line and you bring all of your points parallel across and extend them on out because you don't know the distance yet. And you take every point that you have and you just take them parallel across. And then once you have that done, you're going to get your compass and you're going to set your compass to the distance between the 2 points you were initially given. So that's P2 and P3. And once you have that set, you do not change it. So you go to your next point along the line that you just drew and you mark it. And again, the same, because all we're doing is moving it. So what you do to one side, you do to the other. And you keep marking every point you have, and then you just draw. You draw your object, and that is a translation done. So I will just do a straightforward example here, where we were given A1 and A2, and this is the object A1. We have a circle with a radius 15 mil, and the square is 40 by 40. So the first thing we do is we want to connect points A1 and A2. I'll just do that in the color green. I'm going to do this quite heavy just for your benefit so you can see what's going on. So once that's done, we want to take all of our points parallel. Now this could be easier done with two set squares, but I'm just going to use a T-square for my example. So now that's parallel, we just want to come back and extend every line. Again, you would only want to be doing these as light construction lines, but I will be doing them heavy just for your benefit. Okay. We actually want to bring the center point of our circle as well. So what helps is if you label everything. So this is A1, so we'll call this B1, C1, D1 and E1. So now we A2 here. So again, we want to take our compass and we want to set our compass at distance between the 2 points that we're given. That's the only thing we know. So we take the information we know and we mark off everything that we have. Now, I will connect this up and show you that it will not change anything except the location on the sheet. And then just get our compass, and again we know up here that it's 15 mil for our circle. So set your compass to 15 mil and just draw in that circle. And you can then label your points. So that's A2, so this will be B2, C2, D2, and E2. Now the reason that the points change name is because we want to keep the A, B, C, D, but we want to change for every time we move the object, we want to change the number. So again, now just to finish up, things to remember is you join your two given points, which in our example was P1 and P2. You take all of your lines parallel to the line that you drew for P1 and P2. Once you set your compass from the distance, the only distance that we know, which is P1 and P2, this never changes. What a translation is it creates an exact replica, but it just moves it to another location, another coordinates, but doesn't change the size, width, orientation, anything. And just another thing to remember is do not confuse it with axial symmetry, because that changes the orientation and translation does not.